that lucky old sun. Hey there, stargazers. I'm James Albury, director of the Kika Silva Plot Planetarium in Gainesville, Florida.
And I'm Marlene Hidalgo, science teacher from Miami-Dade County, Florida.
And I'm Dean Regas, astronomer from the Cincinnati Observatory. Have you ever wondered what are stars anyway? And how far away are they? Well, let us unwonder you. Okay, if we could go out any clear night and look up at the stars, could you name the closest one?
Some people think it's the North Star, but nothing could be farther from the truth, because you can't see the closest star at night at all.
You can see it only in the daytime. The closest star to the Earth is our sun.
Yes, indeed our sun is a star, and it's the closest star to Earth. The only reason it doesn't look like the other stars we see at night is because it's so close. And the reason the other stars don't look like our sun is because they are so incredibly much farther away.
Now, all the stars make their own light, much the same way our sun does. You see, our sun and the stars are gigantic balls of extremely hot, mostly hydrogen gas. And even though it might look like it, the sun is not on fire. Our sun shines and radiates immense amounts of energy because of an amazingly powerful energy-producing process that occurs at its core.
The sun's core extends from the center to about a quarter of the solar radius. It's very dense and is at a temperature of close to 13,600,000 degrees Kelvin. Energy is produced in the core by nuclear fusion, which converts hydrogen to helium and releases a whole lot of energy. There's a lot more to it, but that's the important part.
The core is the only part of the sun that produces an appreciable amount of heat through fusion. The rest of the sun is heated by energy that is transferred outward from the core and the layers just outside it. The energy must then travel through many more layers to the surface of the sun, the photosphere, before it escapes into space.
So, the sun releases energy by converting its mass into energy at its core. Or, if you like to think of it this way, our sun produces more energy every single second than several million hydrogen bombs detonating at the same time. So, our sun must be huge.
In fact, it's 865,000 miles wide. Compare that to our tiny 8,000-mile wide Earth, and if you do the math, almost 1.3 million Earths could fit inside our sun.
Another way to think about it is to consider the Earth and the Moon. The Moon orbits the Earth at an average distance of 240,000 miles. We could put the Earth at the center of the sun, and the Moon's orbit would be completely inside the sun with lots of extra room. And believe it or not, our sun is just an average-sized star. There are many much larger.
So when we look at the stars at night, including the stars of the Big Dipper, we are really seeing other suns so far away that they look like tiny pinpoints of light. Most of them are actually bigger and brighter than our sun.
What about our old friend the North Star, who many people think is the closest? Well, it's a whopping 432 light years away, which means we see it as it existed 432 years ago.
Polaris is also often mistakenly thought of as being the brightest star in the sky, but it's actually number 48. Its poor showing is the result of its great distance from us. And although it may not look very bright, it's 2,500 times brighter and 45 times wider than our sun. Wow!
Let's switch over to the western sky and you'll find two bright planets hanging low in the evening sky. The brighter one at the bottom is Venus, with dimmer Mercury above it. They'll be there for the next couple of weeks, Mercury on top and Venus on the bottom.
On the evening of June 10th, a skinny crescent moon will join them for a super planetary sight. They'll be side by side on the 17th of June. So make a note on your calendar to be sure to see it.
Twinkle, twinkle, little star, now we know just what you are.
Keep looking up.